And so what do you think about the research that you are doing now, and how do you think about it in the next few years, the future trends?
I think that, as I mentioned, like earlier, like a few years ago, a lot of people have been just focused a lot on like traditional graph processing algorithms and how to optimize them. One of the things that I've tried to do with my PhD is to show there are like a whole bunch of other unexplored area that we should also look at, with a lot of collaboration with also data mining groups to try to understand like what other things are there out there, and with that, my hope is that as a community we look at this other type of important algorithms that are very different actually. That's what we found in our study than traditional graph algorithms, and hopefully optimize them with real all hardware, hardware solutions like CPU, GPU accelerators, as well as various types of software solutions on really large scale, graphs that can make real impact.
Okay, that's a hard question, I think. I mean, I'm not in no position to, predict the future. I mean, for sure.
You are an expert in that area, growing expert in that area,
okay,
so you will have better thoughts.
I think, so one thing that I really think that might happen in the near future is as a moves law is scaling down, slowing down a bit. So yeah, I mean, performance that are coming from the reducing the feature size, right? I mean, these stuffs are going to be let's say more harder and harder as we go, right? So we as an architect would need to be much more let's say intelligent and much more sneaky to steal 1-2% performance from here and there. And I think as we go, it's going to be even tougher. One thing that I think might be happening is more collaboration with the software writers also, like whoever is writing the programs, right? Some let's say hardware software co-designed approach, which is, I mean, right now, most of the software writers or most of the programmers, right? They are not much aware of the underlying architecture, and basically they don't write code having the architecture in mind, right? Yeah, maybe if I want to bet something, maybe that's probably going to happen. Let's say we need more educated programmers, and they would probably have architecture in mind, and more architects that they would have the software in mind. So
I hope I can, beside doing a great work in my PhD, I hope I can help bring awareness about the discrimination that we do in our CS research. Right now, we are all focusing on the 1% of the population, and we are designing and optimizing everything for already well-developed countries. I hope that it would shed light on the needs of communities that are under-resourced, so we would build web systems that could help them in their day-to-day life, but also help develop their communities at higher level.
From my perspective, the future of computer architecture is going towards, of course, how to scale things better, how to make them more energy efficient so that we can have more computing power. Also with the upcoming of AI and machine learning, we need to do this much better so that it can benefit us in many different scenarios. And we need to figure out how to build hardware or in general machines for this.
If we look how quantum computer find its place right now, we can see the progress comparing with the previous years. So I think it's growing in the community, and I'm very hopeful about it.
Good. So when it comes to research ideas, what is it that gives you the inspiration?
Oh, right. So that's a tough one actually. So in terms of research ideas, right? So the thing that I like the most about the whole process is trying to look at new types of problems and check out like how these different types of like, let's say, workloads behave on traditional techniques that we have in terms of commercial hardware platforms and software techniques. And one of the things that I love about doing research is basically like this whole brainstorming phase, where you get to talk with colleagues, share new ideas, and basically with an open-ended mind think about what is the best way to solve a specific problem at hand.
So I think I had get inspiration from attending conferences, talking to very talented and insightful people. But also I had the opportunity to go to internships and see real world problems and talk to industry collaborators, which was very helpful for me to get a better sight on what's important in day and age.
So this is something that I've learned a lot from my advisor. He basically tries always, this is his favorite term, how can we reboot some aspect? Like if you had to design a system from scratch, what can you do? How can you make it better? And that is something that I try to at least look for, even if it doesn't end up in the final version. How, if I had to design it from scratch, why would I design it a particular way? Why are things designed the way they are today? And then take it from there.
There are many similarities between quantum systems and classical ones, despite there are a lot of differences. But I can say from computer architecture point of view, we can get inspiration from the works that have been done in conventional systems. So I think most of the inspiration comes from computer architecture of conventional systems and kind of adapting them to the challenges that we have in quantum computing systems.
And when you're not doing research, what is it that you do, like hobbies and other extracurricular activities? What is it that keeps you?
Right. Yeah, so we actually rescued a dog last year, and he has been in our lives for a year now. I spent a lot of time with my dog. Initially, we spent a lot of, myself and my wife, we spent a lot of time training him, and then now he loves to fetch, right? So, and run around in the house. So most of the times when I'm not actually working, it's either cooking or playing with my dog, or in terms of hobby, I love swimming as well. Unfortunately, because of pandemic, a lot of swimming pools in the country have been closed. So I'm really excited now that things are turning back to normal. Hopefully, I can spend more time swimming as well.
What
The
else?
other things, I think singing for sure. Expected, yeah. I mean, this part of the India is kind of the same similar hobby. Yeah, I think singing mostly, and guitar,
And musical instruments.
musical instruments. Yeah. Apart from that, hiking is what I love for sure. Like there are lots of mountain places, so yeah, you can always go there and just hike around. Yeah, I think those are my hobbies. Yeah.
I usually, as a hobby, do watercolor painting, so that's my hobby.
Well, that's great. I learned painting myself for about 18 years. Yes.
Being in Switzerland, we are in the center of Western Europe, so that allows me to travel to a lot of different cultures, like France, Germany, Italy, everything is 1 hour away pretty much. And yeah, Switzerland by itself has mountains, it has very beautiful landscapes, so that's very interesting.
Okay.
I like playing board games and also doing workouts in my free time.
So that's good. Okay. Well, thank you, Nargis, for your time. I hope this interview encourages other people to work in quantum. Okay. Thank you.
Sure.